So a function is a relation in which every member of the domain, which is your x values, or your input value, is paired with or mapped to exactly one member of the range, which is your y value, or your output. So your x values cannot repeat. And on a graph, and we'll look at some of those in a minute, use the vertical line test, or a pencil test is what we call it, and to see if it's a function or not. So when you put your pencil down on a graph, your line, whatever they give you, shouldn't cross more than once. So when you're thinking about functions, think about when you guys come in here and I give you a seating arrangement, I tell you which tables to go sit at. You come in here, you are the x value. The y's are the tables, okay? So I say, Trevor, go to table 1. Robert, go to table 2. Z, go to table 3 and 4.
You can't do that.
Can he go and sit at 2 different tables?
Yeah, just like cut him in half.
If we cut him in half, but that's like kind of inhumane and sad, and we don't want to do that. But does that make sense? You're an x value, I can't split you up and you can't go to 2 separate y values. That's what we mean by x's cannot repeat, okay? So if we are given just a set of coordinates and we want to figure out if it's a function or not, say this example 1. So we're given just a set of coordinates. All you want to look at is your x value. Remember, in a coordinate, in an ordered pair, your x value is the first number. That's all you're looking at. Remember we said we can't cut each other in half so we can just sit at 2 different tables. So our x's can't repeat. So I'm circling all of those x values to see if any of them repeat. Do any of them repeat? No. So that means this set of ordered pairs they gave us is a function. They show you a mapping version of it, which looks like this. Anytime there's a mapping, there will be arrows drawn from your x value to your y value. So it's the same set of numbers, so in this case it's a function. If there are ever 2 arrows coming out of one x value to a y value, then it would not be a function. But in this case, there's 1 arrow coming out of every x value, so we're good. We know we have a function. Then if you have a graph, so that's the vertical line test we talked about up there, okay? Or on your paper, if you take your pencil and you hold it vertically, so straight up and down, and you lay your pencil down on this graph, I'm just gonna have to do like, draw a picture. Anywhere you put it, it should only cross your line 1 time. So you shouldn't have any repeating x values. Okay? So it doesn't matter on this first one where I put my pencil, it would only cross and it would only come in contact with one of these dots 1 time. So not a function. If I lay my pencil down, it crosses those dots more than once. So not a function. Most of the graphs you'll see will actually be straight lines. They won't be scatter plots like that. So it'll be a little bit easier to understand. And then a couple mapping down at the bottom. Number 1, determine whether each relation is a function. So looking at number 1, is there 1 x value for 1 y value? Or think about it this way, is there 1 arrow coming out of each x value? Yes. So that makes this guy a function. So then looking at number 2, look at the arrows. And is there 1 arrow coming out of each x value?
Yes.
Yeah. So -1 and +1 are both pointing at 2, but that's okay. Y values can repeat. So y values can repeat. It's your x values that cannot. Okay, so there's still only 1 arrow coming out of every x value. So we're good. None of those repeated. Your x values can't repeat, your y values can repeat. So like I can have two x values, just like you guys. If I say Jansen and Christian, you guys can both go to table 3. Well, that's okay. I don't have to cut either one of them in half. I'm not telling them to go to 2 different tables. They can both go to 1 table.
Okay, Jansen, I think you need to just show.
Okay, number 3, when you're given those ordered pairs, the coordinates, just look at your x value. So look at your first numbers. Do any of those repeat?
No.
So that means we've got a function. Okay, so then let's look at 4, and remember, just look at your x values. So I've got 6, 6, 8, and 9. So function or not a function? Function or not a function? Not a function. Why? Because I have 2 of the same x values. I have 2 6s. Those repeat. I don't want that. That makes it not a function. Same idea if you have a table. You're looking to see, do those x values repeat? So on number 5, I have 0, 1, 1, and 3. So function or not a function?
Not a function.
Function. Do your x values repeat?
Yes.
Yes, I have 2 of the same. I have 2 x values of 1. So that means number 5 is not a function. If any of your x values repeat, don't look at the y's. Just look at your x's.
This is a matter of having eyes.
Then on number 6, look at only your x values. -3, -1, 2, 4. Do any of those repeat? So do we have a function or not a function? A function. We're good. None of those repeated.